Greetings, ladies and gents, and welcome back. It's Mike Maths and Science Club. Today we'll be looking at question 4 on a paper which was written in November 2019. It's a question on functions. So they say that below are the graphs of f of x being equals to x squared plus bx minus 3 and g of x being a all over x plus p. They say that f has a turning point at c and passes through the x-axis at 1 is to 0. They say that D is the y-intercept of both f and g. The graphs f and g also intersect each other at E and J. They also say that the vertical asymptote of g passes through the x intercept of f. Now we know that of course the vertical asymptote would be the line, would be of course for that graph g of x. Now we know that of course that line would be the line that graph, the g of x graph is not allowed to touch. So in this case, so they say that for 4.1, write down the value of p. Now there are two ways you can actually obtain those the value of p. Now there is of course the most common way. Now the most common way in this case would be, now if we know the value of course of the vertical asymptote, so to find the value of p, you just take that value and then you just change the sign. So in this case p would just, let me just put that, so in this case p would just simply be -1. Right, so you just take that that vertical asymptote and then you just take its value and then of course you change the sign. Now another way you can do this, so this was for 4.1. So another way you can do this, of course there is an equation that you can use. So the equation that you can use in this case would be to take that that denominator that we have there, x plus p, and you equate it to 0. So in this case what you would have would be x plus p being equals to 0. So in this case that x would be that vertical asymptote, right, which is we know that we have x being equals to 1, right? So in this case where there's x we would put 1. So in this case we would have 1 plus p being equals to 0. In this case we would know that p actually would become of course -1. So this would be of course the equation that you use to calculate that vertical asymptote if you are given, of course if to calculate the value of p if you are given the vertical asymptote. And of course it can be used the other way around. Now suppose of course they had given you the value of p and they want the vertical asymptote, so in this case you can use the same equation. So in this case, of course, the easier way would just to change the sign of that particular number. So if you know that p is equals to, let's say for example, p is equals to 2. So in this case, the vertical asymptote would be just x is equals to -2. So it would just take the opposite side of whatever number that p has. So in this case, for 4.2, they say that show that a is equals to 3 and b is equals to 2. Now this we actually have a point on that graph f of x. We actually have this point, but also we know also that point that we have there. So in this case we know that that point actually would be the y-intercept, right? So if we look at this graph that we have here, we know that of course this 3 here would actually be the y-intercept. Why? Because in this case that would actually be the value of c, and then we know that of course that value of c is it represents the y-intercept of that graph, if it's a parabola. So to find that value of a of b rather first, so what you would do in this case, what I'm gonna do in this case, I'm just gonna take this value, that coordinate that I have there, and then I'm just gonna substitute on that f of x equation. So in this case what I would have for 4, so we know that this is actually equals to -1. So in this case, to finding the value of b, what you would do would be to substitute that coordinate a, this coordinate that we have here, which is 1 is to 0, right? So in this case, we just substitute on that f of x. So in this case, you would have f. Now we have f of x being equals to x squared plus bx minus 3. So in this case I'm just gonna substitute that point, which is 1 is to 0. So in this case I would know that y would be 0, and of course x would be at 1. So in this case this would be 1 squared plus b multiplied by 1 minus a 3. In this case, we know that 1 minus 3, that gives us negative 2. So in this case, we would have 0 being equals to negative 2 plus b. So in this case, I'm just going to transpose that to negative 2. So in this case, we would eventually have b as being equals to a 2. So in this case, we have proven that b is indeed positive 2. So to find that that the value of a in this case, now remember we have already, so let me just, so in this case I'm just going to erase this so such that we have somewhere to write. Let me just erase what we have here. I hope what I'm saying makes sense. So in this case, so to find the value of a, what you would do, now remember we also know this point that we have, we also know point D, right? So in this case, what I'm going to do, I'm just going to substitute that point D, right? Because it is also on that g of x graph. So in this case, I'm just going to substitute on g of x. Now remember, we know that of course g of x, in this case, the equation is given as g of x. We say that that's a, but remember we found the value of p to being negative 1, right? So in this case, it would be x minus 1. Right, so what I'm gonna do, I'm gonna substitute that point d. So in this case, now remember we would know that of course the x coordinate of d would be 0, right? So in this case it would be 0 being equals to a divided by, in this case we have, no, actually nah, I'm lying. So in this case we have the y being of course negative 3, right? So in this case this would actually be equals to a all over 0 minus 1. Alright, so in this case this would be negative 3 being equals to a divided by negative 1. So you cross multiply, so what you would have eventually is a being positive 3. Now remember, negative multiplied by negative gives us a positive. So in this case we have actually proven that a is indeed 3. So going to 4.3, they say that calculate the coordinates of C. Now remember, we already know. So this would be for 4.3. So we already know that of course f of x is actually equals to x squared plus 2x. Right? In this case, minus 3. Right, so we already know this. Now remember, we have proven already that now even if you didn't get that value, if you are unable of course to prove that a is equals to 3 and b is equals to 2, what you would do in this case would be just to assume that those values are true when of course you are answering the next question. So of course what we're going to do in this case, now there are two ways you can do this. There is of course the grade 11 way where we use the equation of course that says x is equals to minus b divided by 2a. Now this would be when we are actually finding the x coordinate of the turning point. So in this case we would have that being equals to x. Now of course this would be the value of b, so in this case this would be minus 2 all divided by 2 multiplied by 1. So we know that of course a is 1, so what you would eventually get is the x coordinate of the turning point being equals to negative 1. Now of course to find the corresponding y value of that point, so what you would do would be to take that value that you got for x and you substitute it on the original equation of f of x. So what you would have, so in this case to find the corresponding y value, so in this case it's going to be f of negative 1 being equals, so everywhere on that equation where we have x, we're going to substitute negative 1. So this would be negative 1 squared plus 2 negative 1 minus a 3. So in this case what you would actually have, now remember this would give us a negative 5, this would give us a positive 1. So in this case negative 5 plus 1, so this would actually give us a negative 4. So this would actually be equals to negative 4. So in this case we would know that the coordinates now for the turning point would be x being negative 1, and then we know that of course the corresponding y value for that would be negative 4. So the other way you would have done this would be of course on this first part would be to use the grade 11, the grade 12, where in this case which is you would find the first derivative, and then you equate it to 0, and then you just solve for x. So in this case, that that x value that you're going to get would actually be the x value of the turning point. Now what you would do in that instance, so what now remember, we've already know that of course f of x is actually equals to x squared plus 2x minus 3. So what you would do would be to find the first derivative, right? I'm sure you know that. So in this case, this actually becomes 2. Right, so x, remember, to that power we actually subtract 1. So in this case, it would become 1. And then, so in this case, this would actually be 2. Right, and then of course x, so in this case, now remember, this x is an exponent of 1. You subtract a 1 there, you would get a 0, and anything to the power of 0 gives us a 1, and anything multiplied by 1 is just whatever that value is. So in this case, you would take that and then equate it to 0. So what you would get eventually would be 2x being equals to negative 2, and x being equals to negative 1. So in this case, after this, you would follow the same step again, substitute that value of x on the original equation, and of course you would get the corresponding y value for that. So this would be of course for the grade 11, for the grade 12, so rather I should say. So in this case, in grade 11 we would have of course used the first method, and for the grade 12, of course it's still applicable, we can still use the grade 11 method. But of course now we have more options. We can either use the grade 11 or the grade 12 technique, of course, which is finding the first derivative and you equate it to 0. So in this case, for 4.4, they said that write down the range of f. Now remember that the range in this case represents all the possible y values that we can actually substitute into our equation and get a solution. So in this case, we know that, of course, now immediately, now remember, we know that c, we found that to be negative 1 and negative 4, right? So in this case, as soon as we take a value that's actually less than negative 4, in this case, we would actually get an error in our calculator. So in this case, we know that now the reason for that would be now our graph does not exist immediately after that. After, let's say, if we substitute a value, a y value, of course, that is less than negative 4y, because in this case, our graph does not exist down here. So in this case, for the range, so in this case, all the possible y values that you can substitute and get a solution would be to start from that negative 4 up until to infinity. So in this case, the range would be y is an element between in this case negative 4 to infinity. So that, now remember, negative 4 is included, all right? So in this case, so in this case, we know that negative 4 is included in our solution. So what? But remember that infinity, we don't actually know infinity, so that's why we actually do not include it. So for 4.5, they say that determine the equation of the line through C that makes an angle of 45 degrees. An angle of 45 degrees with the positive x-axis, right? Your answer in the form y is equals to something. So in this case, what you would do for that, now remember, they say that we have a line, right, that is passing through point C. So that actually makes an angle of 45 with the positive positive x-axis. So this would be after this portion that we have here. So in this case, we would have our line being either there or somewhere there, but in this case we know that of course it makes an angle 45 degrees, but in this case on this side of the positive x axis. So what you would do in this case for that, let me just erase this so that we have somewhere to write. I just hope that I'm gonna remember all of that. Let me just undo that. Just take a smaller one so that I don't erase everything. So in this case, what you would do is pretty much simple. Now we know that, of course, we know that that line actually passes through that point C, right? So in this case, what we have would be something like that. But we know that whatever graph that we gonna have there must pass through that point C, right? And of course, it must make an angle of 45 on the positive x-axis. Now, it can be also a line that's actually like this, right? But as long as it's gonna make an angle of 45 degrees, now we can actually obtain, we're gonna see which of these lines would make sense. Now, in this case, we know that, now remember, we know from grade 11 that, of course, to find now that 45 degrees would be the angle of inclination of that line that we have there, that is, of course, passing through that point C. Now, to calculate the angle of inclination, we know from grade 11 then we just take tan of theta, and then we equate it to the gradient. So in this case, what we would have would be 10. So if we were to find the angle of inclination of that line, we're gonna say that tan of theta is actually equals to the gradient of that line. So in this case, now remember, we actually have theta. So in this case, we're gonna say tan of theta, but now we don't know the gradient. So this would be tan of 45 degrees equals to m. So in this case, of course, you would actually get m being equals to a 1. So we know that that line that it's passing through point C has actually a gradient of 1. So in this case, we know that the equation would be y is equals to x, right, plus c. Now remember, we also have another point, which is point C. So what I'm going to do to find that point C, that the value of C would be to substitute that point C actually on that point C, in this case, in this equation. So in this case, what I'm going to do, so that's plus C. So what I'm going to do, I'm going to substitute that coordinate. So we know that's -1 is to -4, right? So in this case, I know that this would be -4 being equals to, so in case I'm substituting sub point C. So in this case, I would have -4 being equals to -1 plus C. So in this case, you would actually have an answer of -3 being equals to C. So we know that, of course, also we know that, of course, the value of C is equals to -3. So now we have our equation being y is equals to x minus 3. Now remember that we also know that this graph actually also have a y-intercept of -3. Now remember, the value of C actually represents the y-intercepts, right? So in this case, this graph that I have here wouldn't actually make sense, right? Because we know that, of course, that graph also passes through. Let me just erase and of course put another graph there. Maybe it will make a little bit more sense, right? So we actually have a graph that's exactly look like that, more or less close look like that, but we know that it also passes point D. Now remember that point D has a coordinate of 0 is to -3, right? So in this case, we also know that that would actually be where this graph, the graph of that which is that equation, would actually, it would also be passing through that point C. So they say that, so in this case, our equation, we know that y is equals to x minus 3. So for 4.6, they said, is this straight line determined in question 4.5 a tangent to f? Explain your answer. Now, that's not a tangent. Why? Because we know that that line that we have there actually passes through point C and D. Now they actually mentioned that that line is passing through that point C, right? But you also found out that actually that same graph would actually also pass at point D, because that's where we have actually -3, right? But also that -3 would also be the y intercept, right, of that graph f of x. So in this case, it is not a tangent to the f. A reason for that, we know that because it is passing through also point C and D. So as a result, it is not a tangent, because we know that a tangent, it touches a graph only once and it doesn't touch it ever again. So in this case, since it touches it twice, so we know that this in fact is not a tangent to the graph of f or even that g of x for that matter. So for 4.7, they say that function h of x is actually equals to f where there's x, we put m minus x, and we add a q eventually after that. So let me just erase this again. So in this case, I'm just gonna try to. So they say that of course they say the function h of x f minus m minus x plus q has only one x-intercept at 0 at x is equals to 0. So we know that the type of a graph that we actually have, it actually passes through that origin, this point here. So we actually have more or less the graph that looks like that, but we know that it is actually passing through that the origin. So in this case, we know that of course the coordinates for that would be 0 is to 0. All right. So in this case, what I'm gonna do, I'm gonna try to find that h of x in this case in terms of m and q. So in this case, I know that h of x is actually obtained by substituting where there's x on that f of x, we substitute m minus x. So in this case, this would actually be equals to m minus x, we square that, plus 2, in this case m minus x, plus minus 3, plus a q. So in this case, what I'm going to do, I'm just going to simplify that a little bit. So in this case, I would actually have x squared minus 2mx plus m squared minus, I'm also going to just distribute that. So in this case, we also have plus 2m minus 2x minus 3 plus a q. Now remember that this function that we have here, it actually have a standard equation which says that f of x is equals to ax squared plus bx plus c. So anything that is attached to the attached to x squared would be that value of a, right? But anything that is attached to just x or to x to the power 1, in this case we know that that would actually be b, right? So in this case, what I'm gonna do, I'm just gonna try to rearrange this, because now remember we said anything that is attached to x alone, x to the power 1, that would actually be the value of b, right? So in this case, this, we know that it is attached to x, but at the same time this is also attached to x. So what I'm gonna do in this case, I'm just gonna try to group these two, right, and see if there's something that I can do for that. So in this case, I would have x squared minus 2mx minus 2x plus m squared plus 2m minus 3 plus a q. So what I'm gonna do, I'm actually just gonna take a common factor between these. So what I'm gonna do, I'm gonna say x squared is equals to, I'm just gonna take x as the common factor. So in this case, this would be plus in this case x negative 2 m minus a 2 plus of course m squared plus 2m minus 3 plus a q. Now remember that immediately after I find that the value of m, this would just be a number, this would just be a number, and this would also be just a number. So in this case, this whole thing that I have here would actually just be this part of c, because that is just a constant, a value. So what I'm gonna do now, remember from grade 11, now remember that that point that we have here would also be the turning point of that graph. So it would also be the turning point of that graph. So in this case, we know that the coordinate of the turning point is actually at 0 is to 0. So what I'm gonna do now, remember we said this would actually be this b that we have here. All right. So what I'm gonna do, I'm just gonna use the grade 11 method. Now remember, if we were looking for the x coordinate of the turning point, we were gonna say that x, let me just write that down there so that I have we have more space. So in this case, x, we're gonna obtain it by being by saying that x is equals to negative b, or divided by 2a, in this. Now remember that we know that b in this case would be this portion that we have here. So in this case this would be minus a2 m minus 2. All of this is divided by 2 multiplied by 1. So in this case, this is equals to 0. Now remember, when you have the x-coordinate of the turning point, right, to be 0, we know that it is turning at 0 is to 0. So in this case, what I would do next, let me just erase this so it's that I have somewhere to write. So in this case, what I'm going to do, I'm just going to do my mathematical gymnastics. So in this case, what I would have would be this multiplied by a 0. Now remember, 0 is a fraction, it would just be 0 divided by 1. So I'm going to multiply this by that 0, that gives me a 0. And then I'm going to take negative, I'm going to take this 1, I'm going to multiply it by that numerator there on the other side. So in this case, what I would have eventually would be negative 1 minus 2m minus 2. So this actually be 0 would actually be equals to negative, it would actually be 2. Let me just that is just 2. So this will be 2m plus a 2. So in this case I would actually find m being equals to negative 1. So in this case, what I would do, I would transpose that, divide by 2 on both sides. And remember, when it gets to the other side, it actually changes the sign, right? So in this case, it would be negative 2, and then of course to find m, we just divide by 2 on both sides, and negative 2 divided by 2, that would actually give us a negative 1. So in this case, we know that m is actually negative 1. Now, so in this case, if I were to rewrite that, I would know that of course now we have x squared. Let me just erase that again, such that we have somewhere to write again. So in this case, we have x squared. Now, if I substitute negative 1, so let me just keep it as it is. So in this case, this will be plus x minus 2 minus 1 minus a 2 plus negative 1 squared plus 2 negative 1. Seems like I'm going to run out of space. Minus 3 plus a q, right? So in this case, if you note that this would actually give us a 0. Now remember, this would be positive 2 minus 2, that is 0. Anything multiplied by 0 is just 0, right? So this whole thing here, it actually collapses, it gives us 0. So in this case, what I would do, what I'm going to have next is just being x squared, right, plus 0. But if I take this, what I have, if I take that, now remember, so in this case, negative 1 squared, it will give us a 1, all right? But in this case, this would actually give me a negative 5. Negative 2 minus 3, that gives me negative 5. But in this case, plus 1, that would actually give me negative 4. So in this case, that would be minus 4 plus a q. Now what I can tell you already from this is actually that q is actually equals to 0. I'm sure you can already see that since it is passing through that that origin, so that would also mean that the value of c is also 0. So in this case, this whole thing here must actually give us 0. So but in this case, for this to give us 0, q must actually be equals to a 4. So in this case, we would actually know immediately that q is 4, but of course, for the sake of calculating it, so in this case, what you would do, in this case, would just, so what I'm going to do in this case would be, now I know that this whole thing here must equals to 0. So I know that this whole thing must equals to 0 because we know that this is the turning, that is actually the y-intercept of that graph. So I know that negative 4 plus q, it must give me 0. So in this case, q would actually be equals to negative 4. So in this case, we have obtained that q is negative 4, and also that m is actually equals to negative 1. Now, was there another way you could have found that? Well, yeah, there is also another way. So what you would have done, again, let me just show you, of course, the other way. So what you would have done, now we know that, of course, now h of x, we know that h of x is actually equals to now x squared minus 4 plus q. So what I'm gonna do, I'm just gonna substitute that coordinate there. So in this case, what I would have in this case would be 0 being equals to 0 squared minus 4 plus q. So in of course, as you can note, we actually back here, so this becomes a 0, this becomes minus 4. I transpose it, give me x or q being negative 4. So in this case, this is the end of this video, ladies and gentlemen. If it helped you at some extent, please be sure to like, and of course, if you haven't subscribed, please be sure to subscribe and also hit that notification bell so that when the next video comes up, you'll be the first to be notified. But as the story always ends, ladies and gentlemen, this is Sir Mike signing out. Sharp sharp.